Hi guys, today we are going to study factorization by completing square method, which is the second method of solving a quadratic equation. So first of all, we have to check if the quadratic equation is in standard form. So the standard form of a quadratic equation is ax square plus bx plus c equals to 0. However, in our question, we don't have a 0 on the right hand side. So first of all, we convert it into standard form, which says 11x squared minus 34x. This minus 1, when we shift here, it will become a negative of 1. So we get plus 3 here equals to 0. Since now our equation is in standard form, we start solving it. So the first step of completing square method is you have to make the coefficient of x squared equals to 1. But since here it is 11, so we divide above equation by 11. We get 11x squared over 11 minus 34 over 11x plus 3 over 11 equals to 0. So we get x squared minus 34 over 11x plus 3 over 11 equals to 0. So the next step is you have to move the constant term, or you have to shift the constant term to the right hand side, which equals to minus 3 by 11. So the next step that we're going to do is the crux of this method, or you can say the most important step of this method. What we do is we multiply the coefficient of x by 1 by 2, and after multiplying we add its square on both sides of our equation. That is minus 34 by 11, which was the coefficient of x. We multiply it by 1 over 2 and we get minus 17 over 11. Now we will be adding the square of this term on both sides. So we get x squared minus 34 by 11x plus minus 17 over 11 square equals minus 3 by 11 plus minus 17 over 11 whole square. So we can also write it as x squared minus 34 by 11x plus 17 by 11 whole square, since the square of minus is also positive. So on the right hand side we get minus 3 by 11 plus, since the square of minus 17 is 289 and the square of 11 is 121. So on the left hand side we can write it as x squared minus 34 over 11x plus 17 over 11 whole square. Here by taking LCM we get 121, and we get, since 11 times 3, we get minus 33 plus 289 over 121. So on the left hand side we can write the above expression in the form as x whole square minus 2 times first term into the second term plus 17 over 11 whole square. Here we get 289 minus 33, we get 256 over 121. So here I am going to tell you an important thing that why this method is called as completing square method. Since we have written this expression in this form, and now we can write this expression in the contracted form as x minus 17/11 whole square. So in this way we have completed the square of a term. So this sums up that why we multiply coefficient of x by 1 by 2. Since we have to get a 2 with the middle term, so we multiply it by 1 by 2. In case we had to get a 4 in the middle term, we would have multiplied it by 1 by 4. So on the right hand side we get 256 over 121. So since we have to get the value of x and it is in square, so we have to take the square root of the above equation. So we apply square root on both sides. We get x minus 17/11 whole square. Square root is equal to square root of 256 over 121. Remember, whenever you apply square root, you have to put a sign of plus and minus here. Keep in mind, usually students do mistakes. They put a sign of plus minus after this step. But you have to make sure you have to put a sign of plus minus while taking square root. So here we get x minus 17/11, since square and square root get cancelled. And here we get a plus minus square root of 256 is 16, while that of 121 is 11. So further solving, we get x equals to minus 17/11 plus 16/11, and x equals plus 17/11 minus 16/11. So here we get same denominator, 17 plus 16, we get 33/11, and here we get 17 minus 16, 1/11. So here we get two roots that are 3 and 1/11. After that we can write the solution set that comes out to be 3 and 1 by 11. So we have got two roots since it was a quadratic equation, and the highest degree was to the highest power of the variable. So that's all. Subscribe to my videos, and if you have any comments, I'm open to them. Kindly share it. Thank you.